Hi, Tristan and Jakob. I hope you guys are doing well, and I hope that this is maybe useful to you. I'm sorry that it took me until now. I just realized that I needed to add some more context for people that hadn't read the Orta, Salamans, and Siegmiller paper. So I hope it makes sense now. But if you have any questions, please let me know. So what I'm going to do now is just talk you through these slides, and you can pick what you want to speak on, or if you don't want to use it next week, we can use it at another point. But I think it was useful to put my thinking together in any case. Cool. So what are we going to talk about? Well, as you've already explained and found in More Power to the People, technology is not only labor replacing, it can also be labor augmenting, and it can give workers more bargaining power than they had before. So it's easy to be concerned about the future of work if we only think about the labor replacing aspect of technology, but there are also these augmenting aspects. So what we've got on the left is a picture from Osborne and Frey, basically showing that high-skilled individuals have a lower chance of their work content being replaced by machines in future. And then a meme on the right about how every time new technology comes about, it's going to impact labor dynamics in the labor market. Cool. Okay, so we're interested in how technology has augmented labor demand and how it's automated away labor. What has been written about this before in Sweden? Well, there's a wealth of literature. What we're going to highlight here is a paper that came out in the middle of last year by 3 economists at Uppsala, Poignon, Van Marsveen, and Bengtsson. They write about the social costs that came about with industrialization in the iron mining sector in Sweden. Basically, a new technology came about and it reorganized production in the iron mining sector and consolidated iron forges such that they were fewer in number and they employed more people at each individual forge. So some iron miners lost out. They saw a 10% drop in income and a high likelihood of migrating away from the parish in which they were living at the time. And then some other forges employed more people than before. So what we want to look at in this paper is the shock that came about when electricity was introduced and the new technologies that came along with that. Great. So what we want to ask is, how has electrification specifically augmented labor demand and how has it automated away labor? So there's like two competing forces. On the automation side, if you bring about a new machine, it could replace human work. So an example might be an electrical threshing machine for when you are harvesting wheat and you need to thresh the wheat. You can do it by hand, but if you have an electrical machine, you don't need to employ nearly as many laborers. Then on the augmentation side, new technology also allows people to do different kinds of work. So prior to electrification, the number of manufacturing jobs to create manufactured goods was far lower. And to a lesser extent, maybe we can think about domestic technologies like the vacuum cleaner or the dishwasher, sort of augmenting human labor within the home and allowing women to spend more time in the workforce because they aren't spending as much time at home because they have greater levels of productivity at home. Great. So these are these two forces that we want to look at. Why are we interested in this technology and this period? So we would look at the first half of the 20th century. And basically, there's a lot of change going on at this time. So this figure is from Vattenfall's archive, and it shows that in just 5 years, the share of farmland that had access to electricity went from 5% to almost 40%. So obviously, the way of doing agriculture is going to change a whole lot at this time. That's what we want to look into. Not agriculture specifically, but this period more generally, specifically looking at electrification. Cool, so what questions do we want to ask? How can we measure the new tasks and the new work that emerges over this time period? And how can we measure if a particular technology was a substitute for labor inputs or an augmentation for labor outputs? And a lot has been written on this. Some exciting new papers have come out quite recently. What we're going to talk about in this presentation is a paper by David Orta, Anna Salomons, and Brian Siegmiller. They look at the US American context in the second half of the 20th century leading into the 21st, and they try and quantify the kinds of new jobs that are created and then look at in which sectors these jobs are created. Great, so this is like the template that we're going to work from, but we're going to look at electrification in Sweden in the first half of the 20th century. Cool. So the methodology that Orta, Salamant, and Siegmüller use is basically to compare three different sets of text. And what they want to look at is the similarity between labor outputs or occupational titles and a new type of technology being introduced, and then labor inputs or a description of what the worker does. So an example that they give is a medical technologist. This is the occupational title or the labor output. Then there's a task that, or a set of tasks that these workers do. So a medical technologist will do some tests and then analyze the results and give some feedback on diagnosis, treatment, and the prevention of the disease. And there's also recently been a scandal about a company called Theranos, I'm sure we've all heard of it, where they claimed that they had brought out a machine that could do all of the tasks that a medical technologist would do with just a very, very small sample of blood that they wanted to use. So in this case, if you were to imagine the patent that Theranos would have filed, we can think about the kinds of words that they would have used in that patent. They might have said that this machine can perform laboratory tests and procedures, that it can analyze the data, and that it can give you some kind of input into diagnosis, treatment, and prevention. So there would be a lot of similarity between the new kind of technology brought out and the labor inputs of a particular task, in this case, the work done by a medical technologist. And so we would say that this technology is labor automating. It does the work that a medical technologist would have done. And then we can also think about some other examples of where it is labor augmenting technology that allows workers to be more productive. Cool, and we would call that a labor augmenting technology. Great. So what do we want to test? Well, what we want to answer is, in the Swedish context, do we find the same results of the Orta, Salamant, and Siegmüller paper? They find that in sectors where there are lots of augmentation technologies that raise worker productivity, this is where we find new kinds of work being created. Cool. So we need some sources to answer these questions, and I'm going to return to this a bit later. But for now, I just want to say the descriptive statistics and the figures that we show, they are based on contemporary data from SCB on occupational titles and occupational descriptions, and then on one source of patent data from Google Patents. We have plans to use other sources of data, and we need to digitize these, and we're going to return to this in a little bit. Yes. So here's a schematic of the kind of methodology process. We're going to take these three sources of raw data, process them so that we can compare how similar they are, create a measure of similarity between the patent data corpus and then the occupational titles, the occupational descriptions, and then create our output measures of how much a particular industry is exposed to labor augmentation or labor automation. And what I've done is, in the remaining slides, I've put these three pictures, occupational titles, patent data, and occupational descriptions, in the discussion of each section so that you can kind of keep together in your mind what we're talking about, and which of these three components we're interested in. Okay, so what do we need? The first thing we need is information on new occupational titles and kind of when new occupations are created. So our template paper, Orta, Salamant, and Siegmüller, what they use is a document created by the US Census Bureau called the Census Alphabetical Index. And this records a different set of categories of kinds of occupations that people do and they write in on the census forms. So what they create is a kind of coding aid that collapses down all of the different things that people write in to sort of 20,000 different occupational titles and about 400 occupational codes. So there's the titles and then the codes, which are a smaller set. Great. So this document that is created by the US Census is created about every 10 years, and what they'll do is read in what people write down in the census forms, and then once enough people submit a new kind of occupational title, they will add it to this list of titles that they collect. So if enough people write in, say, artificial intelligence specialist, then they'll add that as a category. So what we need to do is find, in the Swedish context, a similar source of information to try and create the same metric. So here are some examples of new titles that are added to the US Census CAI by decade. So you can see artificial intelligence specialist in the left-hand column was added in the year 2000. So there isn't that much of a lag between when the title comes about and when it's added to this list, which is quite interesting. So the left-hand column of this table shows new occupational titles that are associated with a specific technology. So obviously an airplane designer could only be an occupation once we had airplanes. And same for wind turbine technician. It just simply couldn't exist without the technology being created. Then in the right-hand side are service sector jobs that didn't previously exist. So a sommelier doesn't need a particular technology. I mean, wine has been around for ages, but it's a new kind of work that is created and it's added to the list. Great. So in the Swedish context, what we have to work with for the moment are the occupational classifications from SCB. These include an occupational code and then a set of titles that fall under this code, and I've just put an English translation in the rightmost column. And so we can see that for occupational code 2415, there are 10 titles that fall under this code, everything from an econometrician to an environmental economist. And they all fall under this code, and we can imagine that they were added at different points over time. But we don't have this list at different points over time. This particular list is from 2012, I believe. So what we need is to know how these titles emerge over time. What document will we use for this? Well, we found a fantastic source called the Riksvakanslistan, which is produced by the Swedish Public Employment Authority. It's produced every week, and it's a list of vacancies in 24 different regions and a bunch of different occupations. We have records from 1916 to 1958 at the library in Lund. And so basically what you can see here is it's a table, and across the column headers are different regions. There's each county and then a region for Stockholm in addition. And then on the rows, we've got different kinds of occupations. There's 5 different categories, and the first one, which you can see here, is agricultural work. Great. So what we've got on this Riksvakanslistan, there are the tables, and then below that there's some free text, and I'll show you a picture of that just now. So this free text includes less common occupations that are potentially new or just not that frequent, such that they've been added into the table above it. So what we're going to use for our metric of a new occupation that's reached a certain threshold is when a title moves from the free text section into the table. Great, so that's going to be our metric with this Swedish data. We have access to these lists in the library. We need to digitize them and then measure sort of over time when new occupations are added. Great, so that's occupational titles. We can also, from the same list, get occupational descriptions. So on the reverse side of the list, there are a set of different free text adverts, and in some case, under the special ads, They include an occupational title and then a description of what that person will do. So the second entry on the left-hand column here is for a shop assistant that is a decorator. They need to be free from military service, and they need to know things about porcelain, glass, and writing signs for shops. And so this kind of description tells you what the person will do. So we want to try and extract from these lists occupational descriptions as well. So that's why we've got the two images in the bottom left-hand corner. Great. Okay, I'm going to take a breather. Okay, great. I'm going to move through the next component that we need to look at, which is information on new technologies that are introduced in Sweden. So we've got two sources of patent data that are focusing on electricity-related patents. So patents that include the term electricity in the abstract or claims or description. And here I've got a picture of a Scania patent for an electric truck. So clearly, even today, there are still new technologies being introduced. Great, so we've got two sources of patent data. The first is from Google Patents, which we already have access to and have analyzed. And the second is patents that include the term electricity from the Swedish Patent Registration Office. This is in the bottom panel of the graph on the right. And it's basically showing that the time frame for these patents is much longer. It's all the way from 1880 until today, whereas the Google patents are clustered between the 1960s and the 1980s. In the table on the left-hand side, we can just get some descriptives about the companies that have registered patents at the Swedish Patent Registration Office. Scania, the trucking company, and then Roxtec AB are Swedish companies that register patents quite frequently, and then there are a bunch of US American companies as well. Cool, so what we've done is analyzed the Google patents data, and we can look at some clusters of the kinds of patents that are registered. So what we've done is looked at word co-occurrences across the patent texts, and then made a little network plot of where these go together. And what's quite fun is we get nice clusters that pop out. So in this large section in the bottom left here, there's like a cluster of mechanical patents that use terms like pressure levels and pump strokes. And then there's a cluster that looks at electricity generation, which uses terms like fuel rods, fuel pellets, new fuel. And then there's like an electric instruments section that uses terms like reset pulse or system clock or pulse bundles. So what's quite nice is we can see the kinds of patents that use the term electricity in this network plot. We can also do LDA analysis, where we try and pick out topics based on the co-occurrences of words across these texts. We've told the LDA algorithm that we think there are 4 topics, and it's then looked across the word co-occurrences in all of these documents, and then lumped together words that are specific to each of the 4 topics. So we can see in topic 4, we've got that mechanical cluster again with pressure and valve. In topic 2, we've got like instruments with synchronizing ring, device, color, light. You can imagine that these are like signaling devices. And then in topic 3, we've got like chemical solutions with terms like water, solution, product, invention. What's also quite fun is that it's picked up the English and Swedish for water, even though it's not looking at translating the 2 terms. We've just got patents, some that are written in English, some that are written in Swedish. And going forward, we're going to have to try and standardize that. But for these descriptives, it's quite interesting to see that this water is very specific to topic 3. Cool. We can also look at common registrations. So all of the documents in our Google Patent data corpus are registered in Sweden, And then this looks at the 12 most common other places in which the same patents are registered. And you can just see in this correlation matrix the countries which often register patents, or patents are registered in these countries together. So the brightest cell is the intersection between Great Britain and France. So we can say that of all the patents that are registered in Sweden, as well as Great Britain, half of those are also registered in France, or more than half, 54%. So that's quite interesting. And then we can see some other clusters like Italy and France, Belgium and the Netherlands, and Spain and Italy frequently co-register the same patents. Great. So the next thing we need in our list of 3 things is information on what kinds of tasks are done in a particular occupation. So what we've got is from SCB, the occupational code, the title, and then a description of what that does. And I've included an English translation of the Swedish description. I used a natural language processing translation engine that's trained on Facebook comments, but I think it worked quite well in any case to translate from Swedish to English. And so what we can see is the kinds of words that are associated with a specific occupational title as well as an occupational group, and the co-occurrences across these. So in this graph here, what I've done is looked at the individual words that are used in the occupational descriptions, and then projected these using a clustering algorithm called UMAP. It's quite similar to principal component analysis, but tries to spread things out evenly. And then colored the dots by the occupational group that each occupation belongs to. So each dot is an occupational title, and its position is based on the words that it uses in the description. Great. So what we can see is that in the blue color, managers are easy to separate from other occupational groups, but the other groups are kind of hard to separate based only on the words that are used in the descriptions. So what we've got here is simply a plot of the words that are most specific to each occupation. So the log odds calculation basically looks at where it counts the number of times each word is used across the different occupational groups, and then across each individual occupational group, and divides that and takes the log of it. So the longer the bar, the more specific this word is to this occupational group. We're going to zoom in on managers and professionals in blue and purple, and what we can see is that terms like executive director or manager or acting head are associated with the managerial occupational descriptions, whereas for professionals there are things like models, methods, theories, and environmental, which is also quite interesting. Okay, so this is just a breeze through of the kinds of information that we can get from the occupational descriptions. What we need to do next is to get digitize the data from the Riksvakanslistan, and then sort of look at where these new occupational titles emerge, and then calculate the similarity between patents, which we get from Google Patents and the Swedish Patent Registration Office, and the occupational descriptions. And then we'll be able to tell which occupations have more technology associated with them that is labor replacing or labor augmenting. So that's what we want to get to. If we return to our schematic again, we want to calculate that measure of similarity and then look at our outcome measure of augmentation exposure or automation exposure by industry. Cool, so what's next? Well, we need to digitize the Riksvakanslistan and the patents from the Swedish Patent Registration Office. At the moment they are in PDF format, and we need to sort of extract the text from this and then do the natural language processing and calculate the similarity. Cool, I hope that was clear, and yes.